Hello and good day. We are here in Barangay Tabunan, Borongan, Eastern Samar, and today we're going to perform a habitat analysis using the point quarter method, crown cover measurement, nested flat technique, and density cover board. Alright, so the first method that we're going to have is the crown cover measurement, and to do this, the first thing that we're going to do is to establish a 100 meter transect, and within this 100 meter transect, we're going to establish 5 10 by 10 quadrats that has 10 meters interval from each other. Right, so now that we have established our 100 meter transect, we are going now to establish our first quadrant. So we're going to measure, so from this transect line, we're going to measure 5 meters to both sides, and we're going to make it a quadrant. Now that we have established the four corners of our quadrant, we are now going to measure the radius of the trees that are inside the quadrant. Right, so this is one of the trees that are inside the quadrant. So we're going to measure the radius of this tree, of its crown. We're going to measure the radius of its crown from the center to 4 directions. Okay, so we're going to measure it in one direction, second, third, and fourth. We're going to take 4 radius, and we're going to have the compute for the average of the 4 radius, and that's gonna be the radius of the crown cover of this tree. So the reading for this first tree is 4.26, 4.27, 5.32, and 6.67 meters. We're going to take the average of that 4 reading, and that's gonna be the radius or the crown radius of this tree. So now we are done with the measurements for the first quadrant. We're now going to the second quadrant. So we're going to measure a 10 meter interval from this quadrant, and then we're going to establish the second quadrant after that. Let's go. We're done with the last quadrant for our crown cover measurements. So we're going to process the data now. Right, so the next thing that we're going to have is the point center quarter method. So to do this, we're going to first establish our 50 meter transect line. So it's been laid already, and within this 50 meter transect line, we're going to establish 5 sampling points. So in this case, we're going to have sampling points at 5 meters, 0.5 meter, 15, 25, and so on. So it's going to have a 10 meter interval from sampling point. Okay, so after establishing these sampling points, the next thing that we're going to do is to find that sampling point. Say for example, we're going to have it in the first one, first sampling point. So the first sampling point will be here. So what we're going to do is to divide this into 4, and after dividing it, we're going to measure the nearest and biggest tree in each quarter. So say for example, because this is divided into 4, this one will be 1/4. So we're going to look for trees in this area, and another one from here, and in the 2 other quarters. Then we're going to measure it from this point. Okay. So let's do it. So for this quarter, we have a tree over there. So aside from measuring the distance of this tree to the sampling point, we are also going to measure its DBH, or diameter at breast height. Now there is DBH meter, but since we don't have it, we're just going to measure. We are just going to measure its circumference, and then we're just going to take the DBH, the diameter from this circumference. So now we are measuring 110.1 centimeters for it. So now that we are done with the first sampling point, we're going to move to the next sampling point. So we're going to count 10 meter distance. So right, so this time we're going to do or perform the nested flat technique. It is done by establishing a small quadrat of 0.5 by 0.5, and then the next thing that we're going to do is to determine what are or how many species are inside that small 0.5 by 0.5 quadrat. And then the next thing that we're going to do is we're going to expand that quadrat into a 0.5 by 1 meter flat or quadrat, and then we're going to determine what species or how many species are found in that bigger quadrat that cannot be found in the former smaller quadrat. And we're going to continue that expanding of that quadrat until such time that we won't be able to determine or identify a new species in our bigger quadrat. So let's start. So now we were able to establish our first quadrat, which is a 0.5 by 0.5 meter quadrat or plot. Now we're going to count how many species are found inside the quadrat. So we have 1, 2, 3, 4, 5. Okay. So inside this quadrat we have 5 different species. Okay. So we have 5 different species. Now the next thing that we're going to do is we're going to expand this 0.5 by 0.5 quadrat into a 0.5 by 1 meter quadrat. Now we were able to expand our 0.5 by 0.5 square meter quadrat into a 0.5 by 1 meter quadrat. Now what we're going to do is we're going to look what species can be found here in the expanded area that cannot be found in the first subplot. So there is one cumulative species, and the total number of species is 6. Now, because we were able to find a new species in this expanded area or quadrat, we are now going to expand this again. So now we're going to make this into a 1 by 1 meter plot. Right, so now we are in our third plot. So we expand our 0.5 by 1 meter plot into a 1 by 1 meter plot. Now we're going to look what species can be found in this new area, the expanded area, that can be found in our former plot. Now, because we're able to find again a new species in this new area, we're going to expand this again. So now we expanded our plot into a 1 by 2 meter plot. So now we're going to look again for new species inside this new area. Now, the next thing that we're going to do is to expand this again because we were able to find new species here. So we're going to make it a 2 by 2 meter plot. Right, so now we are in our 2 by 2 meter plot, and as we look at the new space that we have, there are no new species that can be found inside. So all the species that can be found here, we were able to list it inside the other plots. So this is the time that we're going to stop. So all in all, we just have 10 different species in the area. Okay, so that's how we perform a nested plot technique. Alright, so this is the cover density board. It measures 6 feet from bottom to top. So it's divided into 6 sections. Each section is measured 1 foot. Okay, so we put this 66 feet away from here and we view what number can we see. We list it, and based on that we determine how dense is the vegetation. So we're going to place a cover density board 66 feet away from here, and we're going to read the figures that we can see from this distance. Okay? So the density board is located in that area, so we're going to measure 66 feet. Alright, so now that we're done measuring 66 feet from this distance, so we're going to view the cover density board from here, and we're going to list the figures that we can see. Right, so from here we can see 1, we can see 2, we can see 3, we can't see 4, 5, and 6. So we're going to record just 1, 2, 3. We're going to add them, so we have value of 6. Okay, so yeah, so that's how we use the cover density board to measure how dense the vegetation in the area is.